In 1916, Albert Einstein predicted the existence of black holes using his general theory of relativity. However, the term black hole was not created until much later in 1967 by John Wheeler, an American astronomer. For years, black holes remained only theoretical objects until the discovery of Cygnus X1, the first black hole ever found within the Milky Way galaxy. The observation of X-rays from the star's strip stellar material being consumed by a dark object suggested the presence of a black hole. But how big can black holes get? Do black holes increase or decrease in size when they merge? Is there a possibility of explosion when two black holes collide? Despite the popular belief that black holes are cosmic entities that appear out of nowhere, they actually just have strong gravitational pull depending on their size and mass. They grow by consuming more matter as they move in space, much like a space vacuum. They also increase in size and weight. Some of the largest black holes continue to consume matter even now as you watch this video. But how big are they? I'll give you 5 seconds to type in the comments below your guess on the biggest black hole in the whole universe. Finished? Well, here are the top 5 biggest black holes that NASA has found and studied. But before all that, click that red subscribe button and follow us on our journey in discovering and exploring the captivating realm of science, technology, conspiracies, and the universe. Before we explore these absolutely humongous black holes, let's talk about the types of black holes we know. There are 3 types of black holes, with the smallest and oldest being the primordial black holes. These mini black holes are theorized to have formed during or after the Big Bang, when the universe was still a hot, dense soup of particles of protons and neutrons. Was in a period of great compression, a denser area of space can have collapsed into a tiny ball, creating a primordial black hole in a fraction of a second. These black holes are very small, with teeny tiny sizes comparable to a coin or smaller, but with masses same to that of our Sun. That is one small and heavy black hole if you ask me. But because of their size, they are difficult to detect and there have been no existing observations of these black holes. Second, we have the intermediate-sized black holes known as stellar mass black holes. These black holes weigh between a few 100 times the mass of the Sun and are formed from stars containing at least 2 to 3 times the mass of our Sun. In the Milky Way, there's an estimated 10 million to 1 billion stellar mass black holes, but this number could be higher considering the vast number of stars in our galaxy. And last but not the least, the largest known black holes are called supermassive black holes. Some of these supermassive black holes get so big and active that they create quasars. The name comes from the early days of radio astronomy, where these bright sources of emissions were called quasi-stellar radio sources. Much like our beautiful Sun, they reside at the centers of distant galaxies. They can clearly vacuum a mass equivalent to that of 1,000 stars in just 1 year and are surrounded by a massive ring of gas and dust. That is a lot of vacuuming. Supermassive black holes have masses exceeding 1 million suns and even more. Studies have shown that nearly every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the heart of our Milky Way is called Sagittarius A, and its mass is equivalent to about 4 million suns, with a diameter comparable to that of the Sun. As unbelievable as it sounds, there are black holes that are bigger than Sagittarius A, with masses that reach at least billions of suns and move at a rapid speed that increases over time as they suck in more planets, stars, and cosmic clouds along their way. Without further ado, here are 5 of the biggest and meanest supermassive black holes, starting with ones that don't have quasars but still are considered as supermassive black holes. Starting with the galaxy Cygnus A, carrying a supermassive black hole with about 2.5 billion solar masses, aka the mass and size of our Sun, with about 14.7 billion kilometers wide. If it took the place of our sun, it would swallow all the planets and stretch halfway to the edge of our solar system. Because of its insatiable appetite for cosmic matter, it forms a magnetic funnel that causes the disk to churn and gas to spew out, creating an enormous radial lobe that is 500,000 light-years in diameter, surpassing the size of our galaxy by 2.5 times. Our next contestant is a black hole that weighs more than 6.5 billion solar masses and was the first to have its image captured. Positioned in the center of the Messier 87 galaxy, this black hole was visible due to the glowing gas present around its edges, which could easily encompass the entire solar system. Messier 87 or M87 is an elliptical galaxy that houses trillions of stars, a supermassive black hole, and roughly 15,000 globular star clusters, whereas our Milky Way only has a few hundred billion stars and around 150 globular clusters. M87 was first observed in 1781 by Charles Messier, located 54 million light-years away from Earth, and can be seen in May with a small telescope. Moving on to the category of ultra-supermassive black holes, which has a mass of exceeding 100 billion solar masses, possibly millions or billions of times that of the Sun. These black holes are encircled by a rotating gas disk from which the gas falls towards the black hole and generates a massive amount of energy. This energy produces a dazzling and robust galactic core called a quasar that can appear much brighter than the galaxy it resides in, making it one of the most luminous objects in the universe. The galaxy OJ287 has an ultramassive black hole at its center, which is 18 billion solar masses, 40 times larger than a Sagittarius A. This black hole is so big that it can only be compared to 3 solar systems side by side. Surprisingly, this galaxy has not one, but 2 black holes, with the smaller one orbiting around the 18 billion solar masses supermassive black hole. Orbiting this monstrous ultra-supermassive black hole in OJ287 is another black hole. The smaller black hole has a mass of approximately 150 million times that of the Sun. Every 12 years, it collides with the larger black hole's massive disk of gas, producing a dazzling flash of light that's brighter than a trillion stars. This light is so intense that it outshines even the entire Milky Way galaxy twice, and takes around 3.5 billion years to reach Earth. The NGC 6166 is an elliptical galaxy located in the Able 2199 cluster, and houses the second largest ultra-supermassive black hole known to exist, with a total mass of 30 billion solar masses. The galaxy is situated 490 million light-years away in the Hercules constellation and has an active nucleus at its center. It is considered one of the most luminous galaxies in terms of X-ray emissions, and it is believed to have formed due to several galaxy collisions. Shining with the brightest of 100 trillion stars, TON 618 holds the title of the largest ultra-supermassive black hole. As it swallows up galaxies' worth of matter, it becomes visible from 18 billion light-years away. With a mass of 66 billion solar masses, this black hole is so huge that it can be compared to 11 solar systems placed next to each other. This black hole is a hyperluminous, broad absorption line radio-loud quasar with a Schwarzschild radius of 1,300 AU, meaning it has a diameter of about 390 billion kilometers, over 40 times the size of Neptune's orbit. TON 618 might be one of the most massive and brightest celestial bodies in the universe. It is possible that there exist black holes even larger than the ones we currently know about, as our galaxy is just one of millions in the universe. Studying these massive black holes can provide us with valuable information about the universe, such as its age, the nature of dark matter, and how these ultra-supermassive black holes formed. Despite our current limitations, we can continue to observe and learn from these massive celestial objects as they move through the vastness of space. Whether they are as small as a coin or as large as an ultra-supermassive black hole, black holes remain a mysterious phenomenon in space and time. They have no limits and yet shine brightly like a massive ball of light-emitting radiation that allows us to detect them. The universe is a place of infinite possibilities where various events could occur, such as star explosions, planet mergers, or meteor collisions. Despite the advancement in technology, there is still so much more to explore and discover in the vastness of space. Who knows? NASA might find new planets as you watch this video. But that's for the next video. If you enjoyed this video, please hit that red subscribe button and give us a thumbs up to encourage us to make more videos in discovering additional scientific facts and mysteries from around the globe and in outer space.